Alright, we're going to be working on separation of variables. For students that are in my class, it's section 6.3, separation of variables and logistic equation. And we're going to focus on 5 different types of problems here, and we're going to be doing the same thing. So I'm going to give a differential equation, and we're going to separate the variables, come up with a general solution for that, and then we're going to look at a specific point and come up with a particular solution. So the first one is x cubed plus 4y dy dx equals 0. Alright, so the first thing we're going to do is subtract the x cubed, and we're going to have 4y dy dx equals a negative x cubed, and then we're going to divide by 4 because I don't want this constant here next to my y. So I'm going to and multiply by dx. I think we can do that at the same time. So we have y dy equals, if I divide by 4, I'm going to have a negative 1/4 x cubed dx. Alright, so I've separated the variables. Oops, except I've made a mistake, which I've done in the past. So I'm going to erase it right here. Eraser. This should be dy. That's what I want it to be. So this should be dy. And so over here I have my y, and over here I have my x, and I want any constants if I can. I don't want any constant multiplying by y. So I'm going to integrate both sides. And on this case, on this side anyway, on the left side, it's going to be 1/2 y squared, and over here it's going to be x to the 4th. So I'm going to multiply by 1/4 times the negative 1/4. I'm going to come up with a negative 1/16 plus c. Alright, if I would continue with this and just get this in a general form, what I would do now is multiply everything by 2 and get y squared is equal to a negative 1/8 x to the 4th plus c, and then I would take the square root and I get y plus or minus the square root of a negative 1/8 x to the 4th plus c, and this would be my general solution. Solution, let's spell that correctly. Alright, but if I have a particular solution, in other words, I want to find c, what I do is immediately after I integrate, I plug in the point, and the point that I want is 1, 2. If I plug 1, 2 in here, I will have 1/2 times 2 squared is equal to a negative 1/16 times 1 to the 4th plus c, and I will get, this is 4, half of that is 2, this will be a negative 1/16 plus c, and so I would have 2 and 1/16 is equal to c, or 33/16. And so now that's my c. And what I can do up here is now plug my c in. So I have y equals plus or minus the square root of a negative 1/8 x to the 4th oops, what I need to do here, I just made a mistake. Let me erase this again. I don't want to substitute it in here. There we go. What I want to do is now plug in my c at this spot right here. So I have 1/2 y squared equals a negative 1/16 x to the 4th plus 33/16. And I can multiply everything by 2, and I'll get negative 1/8 x to the 4th plus 3/8. And so y is going to equal the square root, plus or minus anyway, negative 1/8 x to the 4th plus 33/8. And this is my particular solution. All right. I'm going to do another one here. So here's my second one. And my second one is tangent of x times y prime equal y prime. Let me back up here. Not y squared, right? Y prime equals the sine of x. So I have the sine of x over the cosine of x times dy dx equals the sine of x. So I multiply both sides by the reciprocal, and I get dy dx is equal to the cosine of x. So dy equals the cosine of x dx. Integrate both sides, and I have y equals the sine of x plus c. That's my general equation, or my general solution. If I'm looking at a particular point, and the particular point that I'm going to choose is 0, 1, I'm going to have y, let me back up again. I'm going to have 1 equals the sine of 0 plus c. Well, the sine of 0 is 0. So 1 is equal to c. So y equals the sine of x plus 1 is my particular solution. All right. Let me do the next one, number 3. And number 3 is x squared plus 4 times dy dx equals xy. So I'm going to have 1 over y dy is equal to x over x squared plus 4 dx. And I'm going to integrate both sides. This is going to give me the natural log of y, the absolute value of y. And this is going to give me, I'm going to let u equal x squared plus 4. du dx is going to equal 2x. That means 1/2 du equals x dx. So this is the same as integrating. Here's my half, here's my du, my x dx is gone, and it's 1 over u. So I have a half ln of u, and the ln of u is the same as x squared plus 4. So I have the half of the ln of x squared plus 4 plus c. Well, that's the same as the natural log of y equals the natural log of the square root of x squared plus 4 plus c times the natural log of e. Well, the natural log of e is 1, And I'm going to go a step further and have the natural log of y is equal to the natural log of the square root of x squared plus 4 plus the natural log of e to the c. Well, that's the same as the natural log of y is equal to the natural log of e to the c power times the square root of x squared plus 4. Now I'm equal to a natural log of both sides, and I can say that y is equal to e to the c times the square root of x squared plus 4. But e to the c is a constant. So I'm going to write the square root of c equals x squared plus 4. And this is my general solution. Now, if I have a particular solution, and let's say the point that I'm choosing is 0, e, well, right here I could say that e is equal to e to the c times the square root of 0 squared plus 4. Well, that means e to the e to the c times 2. Well, I'm trying to figure out, so this is the same as, I should write an equal sign here. This is the same as e is equal to 2e to the c. Well, this means that I could do a couple of different things. I think I'll do, this is the same as 1 equals 2e to the c divided by e, which means I have 1 is equal to 2e to the c minus 1, which means I'm going to come up here, have a little bit more room. I have 1/2 equals e to the c minus 1. So that means the ln of 0.5 is equal to c minus 1. So 1 plus the ln of 0.5 is equal to c. So that means that my equation is going to be y equals e to the 1 plus the ln of 0.5. Put that in parentheses, that's my c now, the square root of x squared plus 4. Well, this is the same as e to the first times e till the ln of 0.5 to the square root of x squared plus 4. These things cancel out, so I have y equals e to the first divided by 2 times the square root of x squared plus 4. And I'm sure there are people out there that said, hey, you could have found that out in a lot easier way. And so this is my particular solution. All right, number 4. And number 4 is x y dx plus e the negative x squared times y squared minus 1 dy equals 0. And so I'm going to have e to the negative x squared times y squared minus 1 dy is equal to a negative xy dx. So that gives me y squared minus 1 over y dy is equal to a negative x over e to the negative x squared dx. Oops, and I made a mistake again with my my dy here. What dy? And this gives me on this side y minus 1 over y dy. And over here this gives me a negative x e to the x squared dx. I'm going to integrate that. And this is going to be 1/2 y squared minus the ln of y is equal to, well, if I do some substitution here and I say u equals x squared du dx is equal to 2x, that means 1/2 du is equal to x dx, which is what I have right here. I'm going to end up having a negative 1/2 e to the u du, and I'm going to end up having a negative 1/2 e to the x squared plus c. And so now I'm going to substitute. This is my, I can't get y by itself, so this is going to be my general solution. And if I had the point, and the point I picked was y sub 0 is equal to 1, that means when I put 0 in for x, y is 1. So I'm going to have 1/2 minus the ln of 1 equals a negative 1/2 e to the 0 squared plus c. So this is going to be 1/2 minus 0 is equal to a negative 1/2 plus c. It looks like 1 is going to equal c. So my particular solution will be 1/2 y squared minus the ln of the absolute value of y is equal to a negative 1/2 e to the x squared plus 1. Alright, last problem. Number 5. And it looks like this. dy dx equals y over x squared. That means I have 1 over y dy is equal to 1 over x squared dx. I'm going to integrate both of these. I get the ln of y, absolute value, and here I get a negative 1 over x plus c. And that's my general solution. Remember, just for those that want to know how I did that so quickly, this is x to the negative 2 power, so when I add 1 to a negative 2, I get a negative 1, which means it's the denominator, and I multiply by the reciprocal. Alright, then I got the point, make sure I have my thing here. Okay, the point 1 comma 3. So I'm going to substitute 3 in for y. I'm going to get negative 1 plus c. Now this means e to to the negative 1 plus c is going to equal 3. That means c e to the negative 1 equals 3. Well, that means c is equal to 3 over e to the negative 1, which is the same as 3 to the e. So that means my constant here is 3e times e to the negative 1 over x power. Now, e has an exponent of 1, and the bases are the same, so you add the exponent. So I can go one step further and say I have 3e to the negative x plus 1 power.